Taking a closer look at the LJ Create EV Motors and Generators Panel Trainer. Our EV Motors and Generators Panel Trainer is designed for safe investigation of the following. Number 1. Operation of the traction motor drive, the power electronics module. Number 2. Different modes of speed and positional feedback. Number 3. Troubleshooting the inverter and associated controllers.
Taking a closer look at the operation of the traction motor drive.
The EV Motors and Generators Trainer teaches students about the construction of a permanent magnet, three-phase traction motor, and the operation and control of the inverter circuit. The onboard three-phase traction motor drives the front wheels, illustrated using light pipes to display energy flow. Connected to this motor are three forms of feedback. These are an incremental encoder, an absolute encoder, a resolver. Driver controls consist of a brake, accelerator, and gear selector. For certain investigations, it is important that the wheels can be driven in reverse. The touchscreen dash display is used to monitor speed, battery charge, temperature, and any vehicle warnings. In addition, this display is used to show a workshop scan tool, and also to insert any of the 16 faults into the trainer. Student activities on this trainer sometimes require specific conditions to be in place. A range of scenarios can be selected during these activities that will fix a particular level of battery charge or battery temperature. For example, setting the battery charge level at a constant 75% allows students to run the traction motor for long periods of time without having to worry about recharging the system. Activities on this trainer are centered around the operation of the power electronics module, known as the inverter unit, and its controller unit. Other related system blocks on the trainer are the vehicle management system, the high-voltage battery and its controller, the HV distribution contactors, the 12-volt auxiliary battery and the heating and air conditioning ECU. These blocks are interconnected with a functional CAN bus. Isolated pins are scattered across the trainer to allow students to monitor waveforms and voltage levels. High voltage levels are scaled for student safety. After switching on the panel, the trainer is energized using the key fob switch. Within the vehicle management system block, the key fob detect illuminates to show that the trainer is active. Pressing the start button, while holding down the brake, brings up the dash display. In this case, showing that all conditions are normal. The HV system can be disabled by disconnecting the service disconnect or first responder loop. The first responder loop can be disconnected, breaking the low voltage HV line. The service disconnect is operated in two stages. The first breaks the HV line similar to the first responder loop, and the second breaks the serial connection through the HV battery, and instantly cuts the output voltage from the HV battery.
Taking a closer look at the different modes of speed and positional feedback.
With the brake depressed, drive mode can be selected, and now the traction motor and wheels can be driven with the accelerator pedal. The accelerator position is fed to the vehicle management system. This in turn sends a signal via the CAN bus to the inverter controller. Individual data packets can be viewed and analyzed via an oscilloscope or CAN bus decoder. Having received an instruction to rotate the motor, the inverter controller sends out 3 sets of PWM signals to the inverter, and 1 set of signals to each pair of transistors or FETs. Each transistor is switched according to the PWM signal, together creating a 3-phase AC output with a frequency that corresponds to the position of the accelerator pedal. From this point on, the frequency of this 3-phase signal matches exactly the speed of the motor generator. With the motor running, students can switch between the modes of feedback and monitor these signals, together with the inverter output current monitoring, as feedback is sent to the inverter controller. The incremental encoder provides two signals that represent the speed and direction of the traction motor. The absolute encoder also provides speed and direction signals, and additionally provides a third signal showing the position of the motor with a resolution of 45 degrees. Switching to the resolver will generate three analog signals that represent speed, direction, and position.
Taking a closer look at troubleshooting the inverter and associated controllers.
One of the primary functions of this trainer is to provide practice with troubleshooting. Instructors have a passcode to open the fault insertion panel. 16 faults are available, covering issues with the motor, PEM, contactors and more. The fault insertion panel provides optional descriptions of each fault. Multiple faults can be inserted at the same time. The troubleshooting process starts with the virtual scan tool. If the system has multiple problems, the codes are listed so that the learner can step through them. Learners then turn to a multimeter or scope to confirm the faulty component. Following a period of learner practice, instructors can insert a selection of faults, lock the insertion panel, then leave the learner to list out the faulty components as an authentic assessment activity. If you have received your panel, we're here to help you integrate it into your program. If you would like to order a panel, please contact us for more information.